Hello guys, the topic for today's video is the basic logic gates. Well, the basic logic gates are the building blocks of any digital circuit, and we have three basic logic gates that are AND, OR, and NOT. Using these three gates, basically we can construct any type of logic circuit. Now I'm going to explain the functionalities of these three gates. Well, these are the gates AND, OR, and NOT, and this is the symbolic representation of each gate. Each gate has two states, the input state and the output state, and each input or the output has two states, that is 0 and 1. 0 means low and 1 is high. The 0 and 1 are the digital representations of voltages, where usually 1 means 5 volts and 0 means 0 volts. Now let's see how the AND, OR, and NOT gates work. The AND gate should have a minimum of 2 inputs. In this logic gate, we have 2 inputs, and as I told, each input has 2 states. So we have total number of 4 states, that is 0, 0, 0, 1, 1, 0, and 1, 1. The AND operation is denoted by a dot, and the output is high only if both the inputs are high. As you can see in the truth table, this is the truth table. In the case of AND, the output is high only when the both inputs x1 and x2 are high. In the rest all cases, the output is low, which is binary 0. And coming to the OR gate, the OR gate is denoted by a plus symbol, and the output is high if at least one input is high. So here if we see in the truth table, the output is low if both the inputs are low. In all the other cases, it's high. Now coming to the NOT gate, it is also known as inverter. It can have only one input. As the name suggests, if the input is 1, at output it inverts as 0. And if the input is 0, then the output would be 1. Now I'm going to show you the simulation of how these three gates work. So this is how a AND gate looks like really, and it can have any number of inputs, 3, 4, or 5 and so on, but its minimum input count is 2. So to power up this AND gate, we need 2 switches and a bulb. We need to connect these switches with the AND gate and the output of the AND gate to the bulb. So now we are going to analyze the truth table. Here both the switches are turned off, or to say they are low, so the bulb is also low. So when I turn on a switch, still the bulb doesn't glow because the AND gate glows only when all the inputs are high. If I switch off the input A and turn off the input B, even then the bulb doesn't glow. When both the inputs are turned on, only then the bulb glows. So this is how an AND gate works. I have an OR gate here and 2 switches again. I'm connecting the light bulb with the output of the gate and the switches to both the inputs of the OR gate. Now both the switches are turned off, so the bulb doesn't glow. But when at least one switch is turned on, or to say at least one input is high, then the bulb should glow. So I turned on switch A, which made the bulb to glow, and now I'm turning on switch B, which also made the bulb glow. and even the two inputs being high, the bulb glows. This is how the OR gate works. Now we have a NOT gate here. A NOT gate can have only one input, a switch to control its power, and a light bulb. Now I'm connecting them. Here the switch is turned off. That means the input is 0. So the output is 1, which means the bulb is glowing. And when I turn on the switch, that means the input is high or 1, the output would be 0, that is low. This is how a NOT gate works. I hope you understood the concept. So like this video and subscribe to my channel for more tutorials. Thank you.